Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Find the number of distinct colors among the balls. Leetcode 3160. In this problem, we are given an integer limit and a 2D array queries of size n into 2. So we can see that here there are 4 queries, each of size 2. And there are limit plus 1 balls with distinct labels in the range 0 to limit. For example, here limit is 4, then we will have 4 plus 1, that is 5 balls. Let's create those balls. And then for each query in the queries that is of the form x, y, we mark the ball x with the color y. And after each query, we need to find the number of distinct colors among the balls. And then we return an array result of size n, that is the size of the queries, where ith result denotes the number of distinct colors after ith query. And note that when answering a query, lack of color will not be considered as a color. So initially when we create these balls, all of them are uncolored and that color will not be counted. Now in example 1, limit is equal to 4, that is we have 5 balls and we are also given n equal to 4 queries. So in the first query, we set the color of ball 1 to color 4. So we apply the color 4 to ball 1 and now number of distinct colors will be equal to 1, which we will set as an answer for query 1. Then for query at index 1, we have to color the ball 2 with color 5. So we will set the color 5 for ball 2. And now number of distinct colors on the balls is equal to 2. So for this query, our answer will be equal to 2. Then we come to query at index 2, where we have to mark the ball 1 with color 3. So we set this new color 3 on ball 1 and number of distinct colors on the balls is still equal to 2. So we will set this as our answer for second index. And now we come to final query at index 3, where we have to color ball 3 with color 4 and number of distinct colors now are equal to 3. And now we are done with all our queries. So our answer will be 1, 2, 2, 3. Let's also look at example 2. Again, we have limit equal to 4. That is, we have 5 balls and we are given 5 queries this time. So for query at index 0, we color the ball 0 with color 1 and number of distinct colors will now be equal to 1. Then we come to query 1, where we color ball 1 with color 2. Now number of distinct colors after this query is equal to 2. Then we come to query at index 2, where we color ball 2 with color 2. So note here that we can actually color the two balls with same color, and in the end we have to return the number of distinct colors on the balls. So here the number of distinct colors is equal to 2. Then we come to query at index 3 and now we have to color ball 3 with color 4, and now number of distinct colors become 3 and the colors are 1, 2 and 4. And finally we come to query at index 4, where we have to color ball 4 with color 5 and now number of distinct colors is equal to 4. And now we are done with all the queries, so our answer will be 1, 2, 2, 3, 4. Now in terms of solution, the naive approach would be to run the simulation like we did in the example walkthrough. So we will create an array of balls of size m plus 1, where m is the limit, and each value in the array will represent the ball's color. Initially, all the balls are uncolored with value 0, and then we will go through the queries, and for each query, we update the ball's color by going to the ball's index as per the query. And after updating the color, we perform the linear scan through all the balls to count the number of distinct color. However, the time complexity of this approach will be O of n into m, where n is number of queries and m is number of balls. This is because for each query, a linear scan to count the distinct colors will take O of m time. And now the question is, can we do better? And the answer is yes. The bottleneck of the naive approach is that we perform the linear scan through the entire array of balls after each query to count the number of distinct colors, which was taking O of m time. And which data structure can help us speed up the computation? You would have guessed it by now. The answer is hashmap or hash set, as it will reduce the lookup time of searching the colors from O of m to O of 1, because we want to count the distinct colors. But the hash set may not be very useful here, because a set will tell us whether the color is present or not, and in this problem that may not be sufficient. Let's take an example for that. In example 2, we saw that different balls could be assigned with the same color. Here, for example, balls 1 and 2 were assigned the color 2. Let's call it C2, and we would have added this color to the hash set. Now suppose later we got the query where we want to assign color C3 to ball 2. So now how will we handle it with the hash set? One way can be we will just add C3 to the hash set and remove C2. But this will not work because ball 2 is still assigned this color C2. So it won't be straightforward. Another way can be that we just add the color C3 to it but we don't remove C2. And now later suppose ball 2 was assigned color C4. Then we will add C4 to the set and again don't remove C2. But now the color C2 is not assigned to any ball but it is present in the hash set. So the hash set will again become inconsistent. So just checking for the presence of color will not help us. We have to also count the number of occurrences of the color. So because of this, we should be using hashmap. So then our approach will be simple. We will create a hash map. Let's call it color map to track number of occurrences of each color. And now for each query, we update the balls color in the balls array like we were doing in the example walkthrough. And to avoid the linear scan, we will be storing the colors in the color map. So then for query at index 0, we have to assign color 1 to ball 0. So we will assign the ball 0 with color 1 and add the color to the map as well. So we will add color 1 with 1 occurrence. And at any point, the number of distinct colors will be the size of the hash map. So for query at index 0, number of distinct colors will be equal to 1. Then we come to query 1 where we color ball 1 with color 2. So we assign that color and add the corresponding color to the map with frequency 1. And now number of distinct colors, that is size of the map, is equal to 2. Then we come to query at index 2 where we color ball 2 with color 2 and increase the frequency of the color 2 in the color map to 2 and set the answer for this query as the size of the hash map, that is 2. Then we come to query at index 3 and now we have to color ball 3 with color 4 and add it to the color map as well. And now the color map size is 3. So the answer for this query will also be 3. And finally for query at index 4, we assign the color 5 to ball 4 and add this color to the frequency map. And the answer for this query will be equal to 4. So this is how we will use the color map to fill in the answers for the queries. And we may have to still consider one more case here. For example, suppose we also had a query like 0, 5. That means we want to set color 5 on ball 0. In that case, we will reduce the frequency of color 1 to 0 and increase the frequency of color 5 to 2. And then how many distinct colors we can see? It is 3, but the length of the hash map is 4, which means we will fill in 4 as our answer instead of 3. So to fix this, whenever the frequency of the color becomes 0, we should also remove the entry from the hash map to get the correct number of distinct colors for the query. And now the time complexity reduces to O of n, where n is number of queries, because we can now count number of distinct colors for each query in O of 1 time by just getting the size of the hash map. And in terms of space complexity, it will be O of m plus k, where m is number of balls in the balls array and k is number of distinct colors in the queries array, which will be equal to number of queries n in the worst case. And now this seems to be an optimal approach. But wait a minute. In the constraints, it is mentioned that limit m can be as large as 10 to the power of 9, but the size of the queries can be 10 to the power of 5. This means that not all the balls will be colored, and we may be wasting a lot of space in the array on these uncolored balls. So why not use a hash map to track the colored balls as well? This way, we allocate the memory for the balls that are actually accessed or modified by the queries array. And now the time complexity stays as is, but the space complexity reduces to O of n. Now let's jump into the code part. First, let's get number of queries n from the queries length and create an answer array of size n. Now let's create the two hash maps, color map to track the count of each color and ball map to store the color of each ball. Now we will iterate through all the queries and get the ball and color from the query. And if the ball map already contains this ball, then we will get the previous color of the ball from the ball map and decrement the count of previous color in the color map. And if the count of previous color now becomes 0, we remove the previous color from the color map. And finally, we update the current color of the ball in the ball map and increment the counter of this color in the color map. And in case this color is not present in the color map, we will get the default count of 0 using get or default method. And finally, the answer for this query will be size of the color map. and once we are done with all the queries, we will return our answer. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.